Okay, new chapter. And what we were doing the last 2 days with those focus notes was just like a little intro. And now we're going to in-depthly go over those 4 different segments you guys learned about. We're going to do one today. We're going to talk about perpendicular bisectors. So you guys have to write that essential question down for me in your notes. So we're going to use the properties of those bisectors to help us find missing measures in our triangle, all right? Can anyone remind me, what is a bisector? Like, what's the definition of a bisector? Splits in half, right? So whether that be an angle here, right, where I'm cutting it in half, or like a side or segment, we're cutting something into 2 equal pieces, all right? So don't forget what a bisector is. Okay, so let's specifically talk about a perpendicular bisector. What does perpendicular mean? What do you think of when you hear the word perpendicular? Yeah, you kind of think of that cross, right? It makes right angles. So a perpendicular bisector is like a segment, a line, or a ray that perpendicular goes through something else at its midpoint. So this is where I think we should use like our colors. Let's highlight. What would our perpendicular bisector be in this picture here? What thing? Yes, well, line R. This guy, yeah, this is the perpendicular bisector. It's making the right angle, and since I have those 2 tick marks, I know that R is the midpoint. So I would highlight that in your notes, and that's our example is RS. Okay? So RS is cutting JK in half perpendicularly. So now we have 2 little theorems about perpendicular bisectors. So we have a point that is on that perpendicular bisector. It's equidistant from the endpoints of our segment. Do you guys know what equidistant means? What's that? Yeah, it's the same distance, right? So what does all that mean right there? So here's CD, our perpendicular bisector, and at any point on this line here would be the same distance away from A and from B. So I think what we should highlight on here are these 2 congruent segments. AC would be the same as CB. I'd highlight, because those are the equal parts. That's kind of the meat of this theorem. Or if you're like a number person, let's say it was 7, then this guy over here would be 7. They're the same distance away.
So those 2 are the same as CD too?
Nope, not the same as CD, but these 2 would be the same. Yep.
So like a tick mark.
They would have, yeah, you could already put 2 tick marks there. Since that one already has 1, you could put 2 there. Yep, good call. You guys remember what a converse is? What's a converse? From like chapter 2. Close, we flip them, right? So the converse of this would be that we would know a point is the equal distance away from the endpoints, then it falls on that segment bisector. Remember, converse means we just switch the order of our sentence. So if we knew that AE is congruent to EB, then CE would be our perpendicular bisector. So as we keep going through this chapter, there's going to be a lot of different segments and weird stuff. And when in doubt, if you have no idea, if it looks like it's equal to something, what should you do? Set it equal to something, okay? So now we're going to find some missing measures here, all right? So what do you guys think AB would be?
4.1.
Right. Here is your perpendicular bisector. So A is the same distance away from B and D. 4.1. Not a lot of work to show on this one. Okay, what about WY? What would that be? 3, because XZ is our perpendicular bisector, or XY, excuse me. Yep, perfect. It's cutting that side in half. Now just a little bit of algebra, same kind of process. So how are we going to figure out what X is? Right, QR is congruent to RT. Yeah, but now we just solve. Did you guys get 5 for X?
Yes.
Okay, just make sure you plug in. $13. You guys get a head start on that next one, okay? Same idea. Label your picture if you need to. What did you guys get for WX? I got 21. Anyone else get 21? 21, okay? What? Oh, you got 20? Oh, okay, okay. Perfect. Awesome. Are you okay there? Do you see what I... Yeah, WX. You get 21? They should be the same. Right? They should be the same, like? Do you see it? Do you see it now? Oh, you probably added 15. Okay. All right, folks. So hopefully, maybe you took away from that task that we were doing the last 2 days that concurrent lines are just lines that intersect at one point. So what would be our 3 lines here? A, B, and C. And where are they all intersecting at? Point B. Good. When you're ready, flip the page for me. All right, so our first big center, maybe a bit of a review from the last few days, but a circumcenter is created when your perpendicular bisectors intersect. Does anyone remember why it's called a circumcenter from the last 2 days? Does anyone remember why? Yes. So when you made your circle on this one, P was the center, and then it went through all of your corners of your triangle like that. Maybe you want to draw that circle with your pencil around there. So it might help you remember the name of this one. So you know what it's called when you put a circle around a shape like that? It's called, anyone know?
Encompass.
That's the other. This one is circumscribed. You scribed around it, so that's why it's called the circumcenter. That might help you if there's a connection there. One thing to note is P is equidistant from the vertices, from the corners of your triangle. So P is the same distance away from A, B, and C there. So maybe we should highlight these three. So I take one of your little markers and highlight those three segments because they're all the same length. They're all the same length. That's what equidistant means. All right, let's list those perpendicular bisectors. So what segments are cutting our sides in half? That's what they're wondering. So which ones are making a right angle and going to the midpoint of a side?
EDF.
That's a point, but I want a segment, right? So D to what? Yep, DP is 1. EP and FP. So I make those one color, and maybe like highlight that color over here so you know that those are what they are. Then we can list them. The order of those letters don't matter either. You have them flipped. Okay, what is our circumcenter, folks? Point P, perfect. And now they want us to list out all of our different congruent segments. So I think let's just go in order of our tick marks, okay? And then you guys highlight with a different color for each one. So if we look here, where's my one tick marks at? Yep, so AD is congruent to DB. That would be our first one. Remember. Remember, each side's getting cut in half by that perpendicular bisector.
CE equals EB.
What'd you say, buddy?
CE equals EB.
Yep, we can do that one. I just gotta get a different color here, so I go orange. Yep. BE and EC. That's my third one. AF and FC. Now we have a pretty long line. Shoot, what's that one for? Close, not that one. Which ones are the same distance away from the corners of your vertices? Yeah, my red ones, right? P is the same distance from each corner, so PA PB, and PC. Those are all the same as well. Yeah. Yep, your circumcenter is the same distance away from all the corners. And I know this is confusing with all these letters, but once you put some numbers in there, I think it will kind of hit home a little bit more concretely. Okay, we ready to try an example like this? All right, folks, we are told that Z is the circumcenter of our triangle, the big triangle, TUV. Let's just go in order, okay? TU. All right, what's the length of TU, that whole side? Not 34. Close, and I see why you would think that. Right, remember X is the midpoint? So those are both 19. And help your future self out. Put a little note here. 19 times 2. So you remember when you're taking a quiz or a test, you can use these notes. Help your future self out. Don't just put 38 because you're not going to know what that means in 3 weeks from now. Give yourself a little note. That's good. Good work. Okay. BY. What do you guys think on this guy right here? Yes. Cut 34 in half. UZ.
15.
Not 15.
21.
Yeah. Right? Here's your circumcenter, and it's the same distance from your corner, so this one's 21. What else would be 21 just for fun?
TZ.
UZ.
TZ, yeah. You guys put that on there too, just so you have it. Okay, now this next one, it gets a little hairy. I'll be honest, it gets a little hairy here. We're looking for WV, but like we don't know anything about this side.
54.
Not 54. I wish it was 17. It's close to 17, but it's not. What kind of an angle is right here if it's a perpendicular bisector? Right. How do you find a missing side of a right triangle? I wish.
5D, whatever this one is.
Pythagorean theorem. How do you guys write this out right here? So for WB, draw yourself a little right triangle. This guy's 15. This is 21, and this is what we're looking for. I just kind of rotated my triangle a little bit. I'll outline it in blue here for you. Okay, do you guys remember which one is your hypotenuse? It is your C, but which number on the board? Yes. And if you don't remember, it's the one across from that right angle. And A and B don't matter, so I'm just going to put 15 squared plus x squared equals 21 squared. And now we have to crunch these numbers out. So remember, exponents come before you add, right, in PEMDA? So we have to square those numbers. We got to figure out what is 15 squared. 15 times 15. 225. Don't know what x squared is. 21 squared? Yeah, 441. Subtract over that 225. Let me know what you get. 216? And how do we undo something squared? Yep, you guys remember how to do that in your calculator? It's second, the top left button, and then the x squared button, so you have the square root, and then 216 equals. So go to 14.7 then? All right, we did it. Kind of a lot of work, but we did it. And our last one here, folks. TV. Yeah, it's got blood. That was a lot of work. Okay, that's enough notes for today. Let's just do some problems on our desk, okay? Maybe keep your notes out as a reference. But grab your expo marker. We're gonna do some stuff on our desk. Okay, we don't need the colored pencils anymore. If you want to put those away.